19th. So may as well put the date. First definition of prism is an object with one pair of congruent bases. So with a cylinder, that pair of congruent bases is the circle. With a triangular prism, the base is the triangle. And with a rectangular prism, the base can be different depending on how you put that rectangular prism. Like if I have just a cardboard box here, this is a rectangular prism. I could stack it this way so that the small part's the base. I could have it this way so this part's the base, or I could lay it flat so that part's the base. So with a rectangular prism, you have multiple ways that you could have the base. A pyramid is a 3D object with one base and then a point at the top. So here we have a cone is a type of pyramid. We've got a rectangular-based pyramid and a triangular-based pyramid. So now we're going to do surface area with shapes that are built of other shapes. So this shape here is a bunch of cubes put together. And so if we're doing cubes, and if you ever want to take cubes and build the shape yourself, you can. We're going to draw the 6 views of the shape, the top side, bottom side, right side, left side, front side, back side. We're going to calculate the area of one face of the cube, and then multiply this times the number of faces in each view. So let's look at what this would look like for this example. Let's see. On your paper here, I want you to just label on that shape that that's your front. Now, if you turn that shape and just looked at it from the front, can you see that you would see those sides? When we're drawing that then, we would see 3 along the bottom, 2 along the top, 2 along the middle, and 1 at the top. This would be our front view. If you look on the next page, that's one of the ones that's labeled as the front view. So what I would like you to try to do on this page, on the side, you have some room in the column, is to draw all of them yourself. Can you draw the front? If you looked from the left-hand side, what would it look like? How many sides would you see? See if you can draw all 6 views. Once you've drawn all the views, then to calculate the surface area, from the top you see 5 blocks. From the bottom 5 blocks, from the front 6, from the back 6, from the right 4, from the left 4. The total surface area will be 5 plus 5 plus 6 plus 6 plus 4 plus 4, which is 30. There was no units given, so I'm going to just say units squared, because remember, surface area is always in units squared. All right, here's your next shape. Okay. This is the front. Top, bottom, front, back, right, left. One of those is wrong. Can you figure out which one is wrong? Okay, I lied. None of them are wrong. But I got you to check them all. If I would have just said, see if these are right, you would have been like, yeah, I'm sure they are. They blah, 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 blah. But no, none of them are wrong. So then this one says, find the surface area, but now each has a side length of 2. So if we look at one square, if we have a side length of 2 here and a side length of 2 here, does it make sense that your area is going to be 4 units squared? Because how do we find the area of a square? Length times width, 2 times 2. 1 square is going to be 4. So when we look at the top, in the top there are 8 squares, and each square has an area of 4. So the surface area of the top is 32. 8 squares on the bottom, each one is 4, surface area is 32. So our total surface area in this one will be 32 plus 32 plus 28 plus 28 plus 32 plus 32. Little mental math to add it up. And we get 180. Oh, I made a little mistake. 184 units squared. So in these questions, we have to find out from the left, right, front, back, top, and bottom, how many squares can we see? And then, what is the area of one square? And find the surface area of each of them separate. So there's one more example here. Find the surface area if each cube has a side length of 3. So again, off to the side, if this is 3 and 3, what's my area going to be? 9 units squared.